Let's continue with our multiplication. So we have problem 3. We're going to go ahead and divide this as we're used to in row 1 and row 2. We are finding A times B, by the way. If we were doing B times A, it would be a different order. So we're doing A times B. Those are the rows, and then this is going to be column 1. There's only one column. So you'll note that there's 2 rows for matrix A, 1 column for matrix B. If we consider the dimensions, this is a 2 by 2, and B is a 2 by 1. So per our last video, you'll note that if these two numbers are the same, then yes, we can multiply. And if we can multiply, the answer will we'll have a dimension of, in this case, a 2 by 1. So we can go ahead and create a 2 by 1 matrix. We will put our left finger on 1 and our right finger on 3. And then we move both fingers at the same time. And we get this set up right here. Moving on to row 2, column 1, we get negative 1 times 3 plus, moving both fingers, 2 times negative 1. Remember that we move both fingers. The left finger moves to the right, and the right finger moves down at the same time. Simplifying this, we get 3 plus 0, and we get negative 3 plus a negative 2, which results in a 3, negative 5 matrix. So we know that the dimension of the answer is a 2 by 1 as predicted. We know that matrix A had 2 columns and matrix B had 2 rows, right? That allowed us to recognize if we can multiply or we can't. If these numbers are not identical in the middle, then we would not be able to multiply at all. However, in this example, they were the same number, and that allowed us to multiply. The dimension of the answer is a 2 by 1. We recognize that only after the fact that we recognize that we can multiply. So if we can't multiply, we don't know the dimension of the answer because there is no answer. However, in this case, we were allowed to multiply, and so the answer was going to be a 2 by 1 matrix. We know that matrix A, of course, had 2 rows. Matrix B had 1 column. Now, G and H are extremely, extremely important, and I want you to consider and reflect on what to write for this. But G and H are of utmost importance. Give a rule for what must happen to multiply any matrix together. So in other words, how do you know if you can multiply 2 matrices? Okay. So hint, you might want to think about the number of columns in the first matrix and how that compares to the number of rows in the second matrix. For part H, give a rule for how to predict the dimension. So for part H, if you can multiply, what would the dimension of the answer be? Again, I would strongly suggest for H, consider how the number of rows in the first matrix compares to the number of columns in the second matrix. I'm not typing this up for you or writing it out because I do want you to stop, think, and reflect. For problem 4, we have here various matrices. I would suggest that we go ahead and decide what the dimensions are for all these matrices. So we'll go ahead and show that. And we want to identify which matrices can be multiplied with each other, 2 at a time. Now, remember, the order matters. So for example, A times B is not the same as B times A when it comes to matrix multiplication. So for example, A times B in this case, right, if we look at A times B in this order, A times B is A is a 2 by 3 and B is a 3 by 1. Could I multiply these two matrices together? Yes, because the middle numbers are the same, because the number of columns in matrix A is the same as the number of rows in matrix B. So yes, we could. However, if we were to consider B times A, well, B is a 3 by 1 matrix and A is a 2 by 3 matrix. Can these two be multiplied in this order? When we consider the middle numbers here, they are not the same. And since they're not the same, B times A is not possible. So we can begin by saying A times B is very much possible, right? That's one answer. But B times A is not an option. Now, if we consider this further, A ends with a 3, right? So if we considered any other matrices whose dimension begins with a 3, they could be multiplied by it. So looking at what we have before us, the only other matrix that we could multiply A by in that order would be F, right? Because of that 3 that it begins with in the dimension. So we can do A times B, we can do A times F. Okay, now, your job, of course, is to identify all possible multiplications that are possible. You don't have to perform them, you just have to be able to identify them. So let me ask you a couple of things. What could we multiply with E, for example? So if we're doing E times something, what could those somethings be? Consider now that E is a 1 by 2 matrix. So whatever we multiply by E has to be a 2 by something matrix, right? Well, we have A, for example. A is a 2 by 3, right? If we did E times A, E is a 1 by 2, A is a 2 by 3. These numbers are the same. So yes, we can multiply. And on top of that, if you want to kick it up a notch, if you can identify multiplication, then go to the next step and say, oh, well, if I can multiply, it will be a 1 by 3 matrix, right? What else could we multiply by E? We could multiply D, G, and H, since all of those, their dimensions begin with a 2. I myself am not exhausting all possibilities. That's something that I want you to really, pause and try to consider and do for yourself. However, let's try one more just for kicks. What could I multiply with I? I is a 1 by 3 matrix. Now, if I'm going to go in this order, I times what is possible? I is a 1 by 3 matrix, so whatever I'm going to multiply this by has to have a dimension that begins with a 3. In other words, a matrix that has 3 rows. So, in this case, B is a possible matrix, so we can multiply by I, and so is F. So take some time to go ahead and really think it out. See which ones you can multiply with each other. See if the order matters as well. For your summary, can any two square matrices be multiplied with each other? Can any two matrices that have the same dimension be multiplied with each other? Explain.